Dear students, now we can study moment of inertia. Moment of inertia. Moment of inertia. It is a mathematical term. It is a mathematical term. It's a mathematical term used to represent a relative distribution of area with respect to a reference axis. For example, suppose we are having a reference axis A, B. We are having an area somewhat like this manner. Okay. Then suppose we are having a small area dA. This dA is at a distance r from this reference axis. Then we can say that the first moment of that small area dA about the reference axis AB is dA into R. Then the second moment of that small area about the reference axis AB is dA into R which is equal to dA into R square. The term dA into R square is termed as second moment of area. If you are considering the whole area, this whole area is constituted with so many small areas. Okay. So if you are considering the whole area, the second moment of that whole area with respect to this AB can be written as, that is, the second moment of whole area with respect to the reference axis AB is equal to integral dA into R square, otherwise R square into dA, integral R square into dA. This second moment of area is otherwise known as moment of inertia, which can be indicated as I. So the moment of inertia of the whole area I is equal to integral R square into dA. Okay. This is the expression for second moment of area, otherwise moment of inertia. Cases. In order to represent the distribution of mass about a reference axis, above term is known as mass moment of inertia. Mass moment of inertia. Earlier, the second moment of area, otherwise moment of inertia, is equal to integral r square into dA. It can also be written as sigma r square into dA. As I said earlier, there are so many, the whole area is composed of so many small areas, and if you are taking the second moment of area of those small areas, if you are taking the sum of the second moment of area of that small areas, we can term as the moment of inertia is equal to sigma r square into dA. Okay. Sometimes this reference axis may be some centroidal axis. Say this point is the centroid of this area A. So we can term this point as C. Then this is one of the axes passing through the centroid. Say it is XX. Say it is XX. Okay. So in some cases we can say in the moment of inertia of this area about the centroidal axis. Okay. So that can be written as IGXX. Or if we are considering the vertical axis, we can term as the moment of inertia of this area about the vertical axis which is passing through the centroid. That can be written as IGYY. Radius of gyration. Radius of gyration. Suppose we are having a reference axis AB and we are having an area A and we are considering a small area dA. This small area dA at a distance r from the reference axis. Then as we have already studied, IAB is equal to integral r square into dA. Okay. Suppose we are considering that area into a small strip. We are considering that area into a small strip. This area into a small strip, and we are having the new reference axis A1, B1, and this small strip is at a distance K from the reference axis. Then we can say that IA1 B1 is equal to A into K square. Okay. Where A is the area of that small strip. Okay. If this IAB is equal to IA1 B1, we can say that IAB is equal to A into K square. Then K square is equal to IAB divided by A. Then K is equal to root of IAB divided by A. And the term this K is known as radius of gyration. Okay. So let me explain radius of gyration once again. We are having an area and the moment of inertia of that area about the reference axis AB is equal to IAB is equal to integral r square into dA. This area is converted into a small strip and which is at a distance K from the reference axis A1, B1. Then moment of inertia of this small strip IA1, B1 is equal to A into K square. Okay. Then if the moment of inertia of this small strip, that is IA1, B1, is equal to IAB, we can write as IAB is equal to IA1, B1. That is IAB is equal to A into K square. That is K square is equal to IAB divided by A. That is K is equal to root of IAB by A. Then this K is known as the radius of gyration.